Good morning everyone. As you know that we are doing our chapter 4 work, energy and power. We have already finished work and energy part. So in this video we are going to start power topic. What we are going to start? Power topic. Before going to start our power topic, first what we will do? We will do a quick revision of work and energy. What do you mean by work? Yes, in physics term, work is said to be done when you applied force and some displacement take place. That means by applying force, if displacement take place, so in the terms of physics, we can say that a work is done. Clear? And work is done. And what do you mean by energy? Energy is the ability to do work. Energy is a ability to do work. Is this clear? And so if we are talking about work, what is the formula of work? W is equal to F into S. W is equal to F into S, where your W stands for work, F stands for force, S stands for displacement. S stands for displacement. Is this clear? So, and its SI unit is joule. Its SI unit is joule, and joule is equal to 1 Nm, because I told you that how you will find SI unit. You know that W is equal to F into S. Clear? The formula of F is Newton into meter. So Nm, and Nm is equal to joule. Is this clear? Now, if we are talking about energy, what do you mean by energy? Energy is a ability to do work. Energy is a ability. Basically, your energy is a ability to do work. Is known as your energy. Clear? And SI unit of energy is also joule. SI unit of energy is also joule. There are different forms of energy. Number 1, kinetic energy, potential energy, chemical energy, heat energy, light energy, sound energy, electrical energy, nuclear energy. But out of these, we have done only 2 energies. What they are? Number 1, kinetic energy, and number 2, potential energy. So let us start with the kinetic energy. What do you mean by kinetic energy? I told you that the energy of a body due to its motion is called kinetic energy. Example, moving a cricket ball possesses kinetic energy, because whatever energy in that ball is due to the motion. Clear? Runner's person consists of kinetic energy. Running motorcycle possesses a kinetic energy. So these all are the example of kinetic energy. And what is the formula of kinetic energy? The formula of, we have done a derivation. So the formula of kinetic energy is half mv square. That derivation is very important. Kinetic energy is K is equal to half mv square, where your m stands for mass and v stands for velocity of a body. Is this clear? Now, what do you mean by potential energy? Potential energy is produced due to its position. Clear? When we pull back the bowstring, that bow consists of some energy that is due to its position. A bird sitting at a height has only potential energy. A bird flying in the sky has a potential energy as well as a kinetic energy. So, what is the formula of here? Formula of potential energy is Pe is equal to mgh. What is the formula of potential energy? Pe is equal to mgh, where your m is stand for mass, g stands for gravity, h stands for height. Where your m stands for mass, g stands for gravity, h stands for what? Height. Is this clear? Now let us start our today's topic, that is power. That is power. See, basically the rate of doing work. Basically, the rate of doing work is known as your power. Clear? So, power is defined as the rate of doing work or consuming energy. Clear? How you will define power? Power is defined as the rate of doing work or consuming energy. Clear? Power is defined as a rate of conservation of one form of energy into another form of energy. So, the formula of power, power is equal to work done upon time taken. Work done upon time taken. So, your P is equal to W upon T, where your P stands for power, W stands for work done, and T stands for time taken. Clear? Or if you will write in terms of energy, so P is equal to E upon T, where E is your energy consumed and T is your time taken. Is this clear? So, power is a work done per unit time. Power is a work done per unit time. When work is done, an equal amount of energy is consumed. So, we can also define as the rate at which energy is consumed is also known as power. Is this clear? Now, here is some points about power. Number 1, power is a scalar quantity. Number 1, power is a scalar quantity. Number 2, SI unit of power is watt. SI unit of power is watt, and it is represented by capital W. It is represented by capital W. And a watt is a power when, what do you mean by 1 watt? A watt is a power when 1 joule of work is done in 1 second, or 1 watt is a power when 1 joule of energy is consumed in a 1 second. This definition is very important. Clear? What do you mean by 1 watt? 1 watt is a power when 1 joule of work is done in 1 second, or 1 watt is the power when 1 joule of energy is consumed in a 1 second. 1 kilowatt is equal to 1000 watt, and 1 megawatt is equal to 10 lakh watt. Is this clear? Another unit of power is called horsepower, that is HP, and 1 HP is equal to, here it is written as 746 watt. The power of engines of car and other vehicles measured by a unit called brake horsepower, which is equal to 1 HP. Is this clear? I am reading this once more. Number 1, power is a scalar quantity. By this you can say that we will consider only magnitude, we will not going to consider direction. The second one is SI unit of power is watt. SI unit of power is watt. 1 watt is equal to 1 joule per second. 1 watt is equal to 1 joule per second. 1 watt is a power. What do you mean by 1 watt? 1 watt is a power, or when 1 joule of work is done in 1 second, or 1 watt of the power when 1 joule of energy is consumed in a 1 second. 1 kilowatt is equal to 1000 watt. 1 kilowatt is equal to 1000 watt, or 1 kilowatt is equal to 10 to the power 3 watt. Clear? 1 megawatt is equal to 10 to the power 6 watt. Another unit of power is HP. Another unit of power is HP, and 1 HP is equal to 746 watt. 1 HP is equal to 746 watt. So, the power of energy of cars and other vehicles measured by a unit called brake horsepower, which is equal to 1 horsepower. Now, if we are talking about the commercial unit of power, so the commercial unit of power is kilowatt hour, that is kWh. Clear? So, the commercial unit of power is kWh. or unit is kilowatt hour. So in your meter bill reading it is also written as kWh. 1 kilowatt is the amount of electrical energy consumed when an electrical appliance having power rating of 1 kilowatt is used for 1 hour, and 1 kilowatt is equal to 3.6 into 10 to the power 6 joule. Try to remember this. 3.6 into 10 to the power 6 joule. Is this clear? So if I will ask that what is a commercial unit of energy, what you will say? You will say that the commercial unit of power energy is kilowatt hour. Is this clear? Now some problems are there. Number 1, our body does 220 joules of work. That means W is equal to 20 joules in 5 seconds. That means time is equal to 5 seconds. We know that P is equal to W upon T. So 20 upon 5. 5 ones are 5, 5 fours are 20. So answer is 4 joule per second or 4 watt. Is this clear? So the power, thus the power of this body is 4 watt. Now the second one is, what is the power of a pump? What is the power of a pump which takes 10 seconds to lift 100 kg of water? Which takes 10 seconds in lift to 100 kg water to a water tank situated at a height of 20 meter. For this, first we will have to calculate M is given to you, G is given to you, H is given to you. You have to find W. Clear? Directly work is not given to you. We know that W is equal to mgh. We know that W is equal to mgh. Just put the value 100 into 10 into 20. So work is 20,000 joule. Now just put the value. P is equal to W upon T. So 20,000 upon T is 10. T is 10 second is given to you. Yes, 10 second. So answer is 2000 watt. Clear? And if you want to convert into kilowatt, so you will divide this 2000 in 2000 with 1000, because 1 kilowatt is equal to 1000 watt. Clear? 1 watt is equal to 1 upon 1000 kilowatt. So 2000 watt is equal to 2000 upon 1000. This 0, this 0, this 0, this 0 cancel. The answer will 2000 kilowatt hour. Clear? Now an electrical bulb consumes 7.2 kilojoule of electrical energy in 2 minutes. What is the power? E upon T. Firstly, you will convert this kilojoule into joule. So you will multiply 7.2 with 1000. So you will get 7200 joule. Time you will convert into second, you will get 120 second. So 7200 upon 120 seconds, 0 to 0 cancel, 12 ones are 12, 12 6 are 6, and this 0 will remain as it is. So the answer is 60 watt. Is this clear? Here not power or not work is given to you. In this power and work done is given in the form of energy consumed. Here the energy consumed is given into kilojoule. So first you will convert this kilojoule into joule, and 1 kilojoule is equal to 1000 joule. So you will convert this 7.2 kilojoule into joules. And here time is also given in the form of minutes. So you will first convert these minutes into seconds. Clear? Now a family used 250 units of electrical energy during a month. Calculates its electrical energy in joules. 250 units means 250 kilowatt. So we know that 1 kilowatt is equal to 3R is equal to 3.6 into 10 to the power 6 joule. So this multiply with 250. So the answer will 9.9 into 10 to the power 6 joule. Is this clear? Now transformation of energy. The change of one form of energy into another form. change of one form of energy into another form is known as your transformation of energy. When a body is released from a height, then potential energy of a body is gradually transferred into kinetic energy, because before falling that body, the body is at rest. The body is at some position, and whatever energy that object is having due to its position, so in that case the energy is in the form of potential energy. When you will drop that object, what will happen? In that object there is some motion, and whatever energy in that object is now due to some motion, and the energy which present due to the motion is known as kinetic energy. So here your potential energy converted into kinetic energy. Is this clear? Now some example. A body is thrown upwards, kinetic energy. Clear? Second form of energy is potential energy. A body is dropped from height above the surface of the earth. First it contains some potential energy, second it contains kinetic energy. Filament bulb, electrical energy, convert into heat. First what you will apply in a bulb? First what happened? It contains some we will apply electrical energy. Now this electrical energy will convert into heat and light energy. Is this clear? Electrical iron, what will happen? You will apply electrical energy. Now these electrical energy will convert into heat energy. Is this clear? Now thermoelectrical power, chemical energy of coal convert into heat energy, and kinetic energy, and then electrical energy. Like this you can convert different types of energy into different, like stove, chemical energy into heat and light, loudspeaker, electrical energy into sound energy, microphone, sound energy and electrical energy. Is this clear? Now energy transformation of hydroelectrical power. We will now describe energy transformation which take place at a hydroelectric powerhouse. At a hydroelectrical powerhouse, a dam is built on a river. Clear? The river water collects behind the dam from a receiver. Like this. This is your receiver. Clear? Now, water stored behind the dam is lot of potential energy because it is stir. Clear? Now, but as such this potential energy is no use to us if however the water is allowed to fall from a great height. The potential energy of a water, now if water will fall from a great height, now your potential energy will convert into a kinetic energy. Clear? If however this water is allowed to fall from a great height, the potential energy of a water changes into kinetic energy. This kinetic energy of falling water is used to drive a huge water wheel. This. Clear? Now turbines which are connected to electricity generates are producing electricity. Now this turbine will produce a electricity. Now this electricity transferred to a generator, and that energy will go through this wire and in the form of electricity. So at a hydroelectrical powerhouse, the potential energy of a water is transferred into electrical energy. Is this clear? And with the above discussion, we conclude that one of the important characteristics of energy that it can be transferred from one form to another. Is this clear? First, this receiver contains some water. At this time the water contains potential energy. Now when this water fall from the great height, that water will convert in that potential energy will convert into kinetic energy, and due to that energy this wheel will rotate. Clear? And this shaft and this will go this generator, and this generator will convert into electrical energy. Is this clear? Now our next topic is law of conservation of energy. Law of conservation of energy. Law of conservation of energy. Energy can be transferred or changed from one form to another. According to the law of conservation of energy, whenever energy changes from one form to another, the total amount of energy remains constant. Or in another word, we can say that when energy changes from one form to another, there is no loss or no gain of energy. The total energy before and after transformation remains the same. Is this clear? Another definition of law of conservation of energy is that we can write that energy can neither be created nor be destroyed. That means whatever energy is before conservation, it will remain as it is after conversion. Is this clear? During conversion of energy from one form to another, some energy may be wasted. For example, when electrical energy is converted into light energy, when electrical energy is converted into light energy in an electrical bulb, then some electrical energy is wasted in the form of heat. Although some energy may be wasted during conversion, but the total energy of a system remains the same. Is this clear? So we will write that energy neither be created nor be destroyed. Clear? So, whenever energy changes from one form to another, the total amount of energy remains constant. When a body is thrown upwards or dropped from the height, the total mechanical energy, that is sum of potential and kinetic energy at each and every point on its path, remains constant. Note that at the highest point of its motion, the energy is fully in the form of potential energy, and at the lowest point, the energy is full of the form of kinetic energy. At all other points, the energy is partially potential and partially kinetic. This I will explain in the example. See, the conservation of energy during the free fall of a body will become more clear from the following data obtained in an experiment in which potential energy and kinetic energy of a freely falling body were calculated at a different position of its downward journey. Ball is at rest. When ball is at rest, that means there is no motion. If there is no motion, that means whatever energy in that ball is due to its position. So here your potential energy is more and your kinetic energy is 0, and 20 plus 0 is 20 joule. As ball is come downwards, what will happen? There is some motion. Now if there is some motion, some energy is due to some motion. Now here your potential energy will decrease and your kinetic energy will increase. Next point, see here, your potential energy decrease, kinetic energy is increase, because वो बॉल नीचे क्यों आ रही है? मोशन की जैसे नीचे आ रही है. जैसे वो बॉल नीचे आती रहेगी, आपकी पोटेंशियल एनर्जी 0 होती रहेगी और काइनेटिक एनर्जी ज़्यादा होती रहेगी, बट टोटल एनर्जी विल रिमेन कांस्टेंट. दिस इज क्लियर. सी, all here is 20. That means your potential energy will remain constant. Clear? Now, conservation of energy in a simple pendulum. A swing simple pendulum is an example of conservation of energy. This is because a swinging simple pendulum is a body whose energy can either be potential or kinetic, or a mixture of potential and kinetic energy, but the total energy will remain same. This I have explained earlier also. So a very simple illustration of the transformation of potential energy into kinetic energy and of kinetic energy back into potential energy is given by swinging simple pendulum or an oscillating simple pendulum. This will become more clear from the following discussion. See here, center position, clear, extreme position, and this is also extreme position. Now center position, that means due to its motion. Okay, this is explained here. Listen here. A simple pendulum consists a small metal ball, and this metal ball is called as bob. Is this clear? This metal ball is called as bob. Now, suspended by a long thread from a ridge support, such that the bob is free to swing back and forth when displaced. Initially, the simple pendulum is at rest with the bob in the center position A. Here it is at center position A. Now, when the pendulum bob is pulled to the one side at position B, to give it potential energy because of a higher position of B with respect to the position A, then release bob starts swing. Now, when the pendulum bob is at position B, it has only potential energy because it is only due to its position now. Okay, its potential energy gets on decreasing, but its kinetic energy goes on increasing. When the bob reaches center position A, it has only that kinetic energy. Now, as the bob goes from position A to position C, then its kinetic energy decreasing or its potential energy increase. So like this, we can say that transformation of energy can take place. And with this, we can conclude that total energy of a swing pendulum at any instant time remains same or conserved. Is this clear? That means kinetic and potential energy will increase or decrease, but the total energy, that means the sum of potential and kinetic energy, will remain constant. That means energy can neither be created nor be destroyed. With this, we have finished our physics chapter 4. I don't think so you have any doubt and query. If you have any doubt and query, you can ask me anytime. Thank you and Sairam.